In this video, I'm going to introduce you to a couple more functions that can be very useful in your models. The first function is going to be the min and also the max function. Right? Min and max can be very useful just to find the smallest or biggest number in a certain array. So in this case, we have a set of loans, and we might want to know what our biggest loan and our smallest loans are. So we can use min, highlight our entire row of data. Now I'm going to set this up a little bit specifically, and I'm going to lock only the row references. So I'm going to lock from row 6 down to 19, and you'll see why in just a second. So I see that the minimum loan is $103,675. If I copy that down a cell, now I'm going to change this formula to do a max. Let's go ahead and change my min to a max. And I can see my biggest loan is $490,387. Relatively straightforward. I also might want to just take this same formula, and let's just copy it over to column D. That'll allow me to get the min and the max of my interest rates. Notice it's in dollars, so let's flip that over to interest rates real quick. Control-Shift-5 is what makes that conversion. I center it real quick with Alt-HAC. And then we see the minimum interest rate is 3 and the maximum is 12. Now you can see why it was I locked only the row references initially. I wanted to allow the column to float so I could do the min and max both of column C and then of column D. So a lot of times when you're locking your cells, think forward to how you might be using them. And I knew I wanted to drag that to the right and copy it over, so I only locked the row references and not the column references. So now we can see our minimum loan amount, maximum loan amount, and the interest rates. Note that importantly, that does not mean that this $103,000 loan has a 3% interest rate. It's just the minimum interest rate from that entire spreadsheet. Okay, so that's min and max. Some other functions we might like that are useful. One is sum. This is one that you, I'm sure, are familiar with by now. But we could add up the total value of our portfolio. Right? We see that it's $3,416,000. So what else is something we'd like to know about our portfolio? Well, oftentimes you want to know what the average interest rate is on your portfolio. So one way to get that is to do an average. Average is a function, is another standard function. And we see that the average interest rate is 8%. If we add a couple decimals, it's 7.79%. Right? But that's an equally weighted average. This is probably not what we want. Equally weighted means that every one of these observations got equal weight. So it's just the average of these numbers. But that's not really appropriate when we're looking at a loan portfolio, right? Because what matters more is that this really big loan has a really low interest rate, right? The bigger the loan, the bigger the effect of the average interest rate on the true whole portfolio of assets. So in that case, we need to be able to calculate a weighted average interest rate. Right, so to get weighted average, there's another function we can use. In this case, the Sumproduct function. So what the Sumproduct function is going to do is multiply two arrays together. In this case, we want to multiply the loan amounts times the interest rates. So you can see we have two arrays here, a blue array and a red array. And what it's going to do in Sumproduct is multiply the corresponding values that are right next to each other. So the first one is 113,539 times 11%. It then adds that to 313,129 times 10%, and so on down the entire set of arrays. So in this case, we run and get our answer, and we get a number that's not a percentage. And that's because we've multiplied by the loan amounts. So the last thing we have to do is come back into our formula, divide by, in this case, we need to divide by C20, which is where we summed the total value of our portfolio. So we're normalizing by the portfolio value now. And now we see 7.66% is our weighted average interest rate. So Sumproduct is very useful for getting those weighted averages rather than just a straight numerical average. The last thing that we want to know in this portfolio is first how many loans we have and how many loans we have in default. So in late or in default status. So two functions we can use here. Let's set this up as we're going to have count and count A. So count does just exactly what it sounds like it does. It just counts the number of things. So in this case, it counts how many things it sees from rows 6 through 19. And you see 10, right? But 10 isn't exactly what we expect, right? If we just eyeball this, we see real quick there are 14 rows there. We can actually see at the bottom of our spreadsheet here, if you look down at the corner, it says, see, I'm covering it up, it has a 14 down there right at the bottom. It actually counts it for us down there if you ever need to see a quick count. So what it's counting, though, and this is important to know in the distinction between count and count A, is that count only counts the number of numbers that it sees. So only the numbers. And it turns out there are 10 zeros in these 14 cells of data. On the other hand, count A tells us exactly just how many cells there are with values, either numeric or text. So it also counts the late, the default, and the next two lates as well. And so in this case, if we want to know how many loans are in default or in trouble, so loans in trouble, well, we can take our count A minus our count and get our value of 4. And it seems like my Excel is locked up just a little bit. You know, this is somewhat useful. If your Excel ever does lock up, it can often be because you actually have other spreadsheets open at the same time. So I just clicked over to a different spreadsheet. Now it works again. So I can do 14 minus 10. We see that we have 4 loans in trouble. I also did just auto expand that. Alt-HOI allows me to auto expand the width of the cell. So in this worksheet, in this video, we've seen min, max, we use Sumproduct, as well as count and count A. All are useful functions to have as we build our models.